Hello everyone, welcome to this channel. So in this video, we will continue to introduce some terminology in probabilities. In last video, we already talked about what is event and what is a sample space. And both of these two terminology in fact is a site. So in this lecture, we will introduce the rules of sites. So the first computing rules we want to introduce is intersection. So this is if we have two events, we denoted them by the E sub 1 and E sub 2. Then the intersection of this one is denoted by this symbol. E, you can think this is like upside down U and E2. When we call this E1 intersect E2. And in fact, the meaning of this one, if you learn the programming before, this is really similar with the logic rule. And so it means the elements E1 intersection E2 is the elements in both these two sides. So we can use the Venn diagram to show the meaning of this one. So here we use this rectangle to show this is our S, so this is our sample space. And then we use two circle 1 and circle 2. This is our show of the E1 and E2. So the intersection of E1 and E2 is a covered part. So this is a shadowed part. So this is our E1 intersection E2. So this graph is a Venn diagram, and this is a very important method to show or visually show the meaning of some computing rule of size. Okay, so this is the first computing rule. The second one we want to introduce is the union. So the union of sides is also union of several sides. So here, like union of two sides, E1 and E2, we use a capital U to show this rule. And if we explain this, this is very similar of the logic rule OR. So it means the union of E1 and E2 is elements in either of E1 or E2 or in the in both of them. So similarly, we can use a Venn diagram to explain this meaning. So here you can see in these pictures the shadowed part is covers the part of the union of E1 and E2. So this is also we use a Venn diagram to show the meaning of this one. So the last computing of this size is a complement. So for the complement of a site, so different with the intersection as union, we can say intersection of two sides or several sides, union of two sides or several sides. However, for complement, this is do it for one side. So if we think about the logic, this is very similar to the logic NOT. So it means this is shows the elements not in one side. And the symbol of the complement, we have two ways to denote this. So we can use the E upper C, short for the complement of E. And also in some textbooks, we use the prime to say E prime to say this is complement of E. So both of these two symbols are correct. It just depends on the textbook you use. Okay, and for this one, similarly with the previous definition, we also use the Venn diagram to show the meaning of this. So the only difference is here, instead of have two circles to show two events or two sides, here we have only one circle to show one side E, and the complement of this E is a part not inside this circle. So in other words, this is contains the elements in the sample space S, but not in this circle. So this shadow part is our complement of E. Okay, so this is a three computations of size, or say in ones. And I also want to introduce some computing rules about this site. So the first thing I want to introduce is the one meaning of two sides, or relationship of two sides. This is mutually exclusive of two sides. So the definition of this one is if we have E1 and E2 are two sides, then if we say E1 and E2 are mutually exclusive, that means we will have E1 and intersection E2 is an empty set. So here, this symbol, you can think this is all with a half inside. So this symbol means the empty set. So empty set here it means this is nothing inside. If we denoted this, this is something nothing inside, look like this. So also we can show this relationship by the Venn diagram. So this means we still use a rectangle to show the sample space, and we have two circles to show the E1 and E2, but these two circles won't have any intersection with each other. So this is what's the meaning for the mutually exclusive. Okay, so here if you want to know some example about this, so let me give you maybe two examples about this. So the first one is if we roll a 6-size die, then the two events we interested is the first E1 is we get the 4, and E2 is we get 5. So of course we can know this E1 and E2, they didn't have any elements in common, right? So this means the intersection of E1 and E2 is an empty set. And this also means our E1 and E2 are mutually exclusive. Okay, so this is one example about what is mutually exclusive. So the another one is maybe you can think this is an example, or this is like access. So what is this? This is if we have one diagram, and this diagram is we still use a rectangle to show the sample space, but now we have 3 in 1. So they are denoted by E1, E2, and E3. So then the question is how we can find the some events of this, like E1 intersection E2 intersection E3. What is this? Or what is the question of like the complement of E1 intersection the complement of E2? Okay, so here in this one, I just give you one answer of this. So the answer for the E1 intersection E2 intersection E3, I show this by this shadowed by the green color. So this actually is the part. So I will make this as not shadowed, but I will use this as a color, solid color by the green color. So this is our intersection of E1, E2, and E3. Okay, and then the next one, I leave this as access for you. But before this one, let me give you one law of our computing of size. This maybe will help you later to compute or find the intersection between complement of these two sides. So this is the distribution laws and Demorgan loss. So for this one, in fact we will have the premises in this laws. So in the left hand side, you can see there are two equations. The first one is we use the premises to first compute the union of E1 and E2. And then after this premises, we will compute the result of this with the intersection of our E3. So this is the order of our computing. So this is actually very similar to the computing of plus and minus. We also use the premises to help us change the order. And then what this meaning? So this will equal the E1 intersection E3 premises and then union the result of E2 intersection E3. So this is what is our distribution law. So if you want to find a way to remember this, so in fact this is a little similar to the way we use distribution of plus and addition. So here you can see if on the left we have 1 plus 3 premises times 5, right? The distribution for the plus and addition, multiplication and plus here is also 1 times 5 plus 3 times 5. And we also can use the premises here. But here we can ignore premises because we have the multiplication is do first compared with addition. However, for the union and intersection, we didn't have this rule. We always do this from left to right. So that's why here in this equation, we will use the premises to know. The first thing we will do is the intersection of E1, E3, and also the intersection of E2 and E3. And then we will union the results of these two intersections. Okay, and then similar for the second equation, what we will do is we also have another of the distribution rule. So this one we will have the union of E1 E3 intersection the result of union of E2 and E3. Okay, so this is the distribution laws. And another, and also the last topic I want to cover in this lecture is the Demorgan loss. So Demorgan loss is also about set, but here this is a more focus on the complement. So here we also have the premises. So we have the premises of E1 intersection E2 and then compute the complement of this result. And then by the Demorgan loss, this is equal the E1 complement union E2 complement. So here the very important part is previous in the premises, this is an intersection, and after the Demorgan's law, we have this is changed to union. This is very, very important because from my experience, students always meet problem and always make mistakes when they answer the question and use this rule. So please careful about this Demorgan rule. And also here, we also have similar one for the result of union and complement. So this we will, if the inside of this premises is union on the left hand side, then on the right hand side it will change to intersection. Okay, So this is, we also change these two computation here from the union to intersection. So you should know in the Demorgan's law, it always change the, you can think change u to the upside down u, or change the upside down u to the classical u, something like this. But just remember this when you do some questions. And also, if you want to have an access, actually you can use the Venn diagram picture to help you to explain why this left-hand side is equal to the right-hand side for our distribution laws and Demorgan loss. Okay, so this is a materials for these lectures. In our next lectures, I will continue something about the size and events. So that is about the computing techniques, or we call this multiplication rules, for how to find the outcomes in the events or size. Okay, so please subscribe this channel and see you in our next lecture.